What if we already received the call from an alien civilization and simply never noticed? We are scanning the skies with everything we have, while the answer may have been sitting in our data for decades. The wow signal, that strange object from another star system that passed through ours, we have the receipts, just not the translation. So is the silence coming from the universe, or are we the ones who are deaf? We accept the silence because the numbers seem to demand it. The universe is roughly 13.8 billion years old, a figure so vast it defies our daily sense of time. Within our own galaxy, the Milky Way, we estimate there are between 100 and 400 billion stars, a number that is more an admission of our own uncertainty than a precise count. In 1950, the physicist Enrico Fermi, during a lunch at the Los Alamos National Laboratory, looked at these staggering figures and famously asked, "Where is everybody?" This question became the seed of the Fermi Paradox, the stark contradiction between the universe's immense age, its countless potential homes for life, and the thunderous silence we observe when we look outward. We are not talking about a handful of candidates. The potential for civilizations is not just a philosophical whim, it has been given a mathematical foundation. In 1961, Frank Drake presented his famous equation at the first scientific meeting on the search for extraterrestrial intelligence at the Green Bank Observatory in West Virginia. His formula, with its 7 variables, was designed to estimate the number of communicating civilizations in our galaxy. Plug in optimistic values for the rate of star formation and the fraction of planets that develop life, and the equation can yield a staggering result. As many as 10 million civilizations. That is not a lonely figure. That is a number suggesting a galaxy teeming with intelligent life, with voices, with signals broadcasting across the void. But there is a catch. When we look out at the stars with our most sensitive instruments, we hear only the cold, aimless hiss of cosmic background radiation and the random chirps of pulsars. We do not hear the chatter of a million worlds. We do not pick up the faint echoes of alien engineering. The contradiction is glaring. The math suggests the galaxy should be a loud, bustling metropolis, and yet we find ourselves in what feels like an empty desert. So why the disconnect? Is the universe truly silent, or are we, in a way that we haven't yet understood, fundamentally deaf? We have assumed our methods are correct, our frequencies are right, and our interpretations are sound. But what if the failure is not on their end, but on ours? The paradox might not be about their absence, but about our inability to perceive a signal that has been passing through us all along, like a radio broadcast in a room full of people without a receiver. But we do have a receiver, and we have had one for decades. It sits in a valley in West Virginia, a steel giant named for the man whose name is now attached to the very equation that predicts 10 million voices. Since the 1960s, we have pointed it, and its successors, at thousands of nearby star systems, scanning narrow bands of the radio spectrum, listening for a tone that is not natural, a pattern that does not belong to the physics of dead matter. And for the most part, the output has been a monotony so profound that it could drive a lesser mind to despair. The data streams in as a flat line, a graph of static that looks like the heartbeat of a comatose patient. The silence does not feel like an absence of signal. It feels like an active, deliberate refusal to speak. A universe that has closed its doors and drawn its blinds, leaving us standing outside in the cold. That is the heart of the Fermi Paradox laid bare. The contradiction is not just a matter of numbers, it is a matter of scale that defies human intuition. The universe is 13.8 billion years old. Our galaxy alone contains between 100 and 400 billion stars. If even a fraction of a percent of those stars hosted a planet with the conditions for life, and if even a fraction of that fraction developed intelligence, and if even a fraction of that intelligence figured out radio technology, the numbers would still be gigantic. The galaxy would be filled with signals so dense that our radio telescopes would struggle to isolate a single voice from the crowd. The night sky would shimmer with the infrared glow of megastructures. We would see the waste heat of civilizations that have learned to harness the energy of an entire sun. Yet we see nothing, not a whisper, not a flicker. The conflict between what the numbers demand and what our instruments report is not a minor puzzle. It is a screaming, unresolved alarm bell that has been ringing since a small gathering of scientists shared a casual lunch in 1950, when Enrico Fermi looked up at the sky and asked, with the calm of a man stating an obvious fact, "Where is everybody?" Now pause for a moment and let the weight of that question settle into your chest. The discomfort you feel is not from the idea of being alone. It is from the realization that the equation, the very tool we built to calculate the number of our cosmic neighbors, has only succeeded in making our loneliness feel more absurd. The equation is not wrong, it is incomplete. It is a framework that assumes we know what we are looking for. But do we? For 60 years we have listened for a narrow band of frequencies, operating on the assumption that any advanced civilization would communicate the way we do. using radio waves that penetrate the atmosphere. But what if radio is the equivalent of smoke signals in an age of fiber optics? What if the signal is not a continuous hum but a singular fleeting pulse, a moment of brilliance that lasts no longer than a solar flare? What if it has already come and gone, and we were looking in the wrong direction when it passed? Consider for a moment a single data point. In 1977, a telescope in Ohio detected a signal that was so strong, so narrow, and so exactly the shape that we predicted for an extraterrestrial transmission, that the astronomer who noticed it wrote the word "wow" in the margins of the printout, a spontaneous burst of astonishment that has echoed through the field for half a century. The signal lasted for exactly 72 seconds, a blink of the cosmic eye, and then it was gone, never to be heard again. It came from a patch of sky in the constellation Sagittarius, and despite decades of re-observation, no one has ever found a repeat. What was it? We still do not know, but the memory of that brief, inexplicable burst of energy suggests a terrifying possibility. The universe may not be silent at all. It may be broadcasting in a language of rare, unpredictable events, signals that flash for a minute and then vanish into the noise, a cosmic lighthouse that sweeps its beam across the void with no concern for who might be watching at the exact moment the light passes. It was the summer of 1977, and Jerry Eman was sifting through stacks of computer printouts at Ohio State University's Big Ear Radio Observatory. He was a volunteer astronomer, spending his days staring at rows of numbers that represented the static hum of the cosmos. On the morning of August 15th, he was checking the data from the previous night when a sequence of characters jumped off the page, 6EQUJ5. It was a signal that rose sharply in intensity and then fell away, a neat, tidy bell curve of a transmission that looked absolutely nothing like the chaotic noise of space. It was so striking, so unexpected, that he grabbed a red pen, circled the sequence and wrote a single word in the margin that would become a legend. Wow, that's it. No analysis, no long explanation, just a moment of pure, unfiltered astonishment. He had just stumbled upon the most promising candidate for an alien communication ever detected, a moment that seemed to crack open the door to the universe and show us a sliver of something waiting on the other side. What made this signal so profound wasn't just its shape, but its frequency. It arrived at 1020 MHz, a specific band of the radio spectrum that is the natural emission frequency of neutral hydrogen, the most abundant element in the universe. This quiet, universally recognized frequency is so significant that SETI scientists call it the water hole, theorizing that it's the most logical place for civilizations to meet and communicate, a sort of cosmic oasis. The signal was also incredibly powerful, clocking in at a staggering 30 times the intensity of the background noise, a clear and forceful shout in a sea of whispers. This combination, the unique frequency and the immense power, made it almost impossible to dismiss as a random cosmic event. For a moment, it felt as if the universe had paused, listened, and then deliberately spoken our name. The signal lasted for a full 72 seconds, the exact duration the Big Ear telescope could track a fixed point in the sky as it rotated, and then it was gone, swallowed back into the silent void. But here's the part that still haunts astronomers nearly 50 years later. It never came back. For decades, scientists have pointed the world's most powerful radio telescopes back at that exact patch of sky, in the constellation Sagittarius, listening with all their might. More than 100 times, they have tried to recapture that single, beautiful note, and every single time, they have heard nothing but the quiet, empty hiss of the universe. The leading explanations have all crumbled in the face of scrutiny. It probably wasn't a comet, it likely wasn't a solar flare, and it doesn't easily match any human-made interference from Earth. So, what was it? Jerry Eman himself, in the years before his passing, never knew for sure. He spent the rest of his life wondering if he had witnessed an alien civilization trying to reach out across the void, or if he had caught the tail end of some exotic, natural phenomenon that we simply don't understand yet. He had inadvertently picked up a call that defied explanation, a call that offered no message, no context, just a single, powerful hello before the line went permanently dead. So, what do we do with this? We hold it as a profound, unresolved question. We have a 72-second call that we recorded but never understood, and a silence that has persisted for over 50 years. And that makes me wonder, if we can catch a signal like the WOW signal and still have no idea what it was or where it came from, then what about all the other subtle messages that might be floating past us? If our most promising discovery is a complete mystery, what hope do we have of recognizing a more complex conversation? And this leads me to a far more uncomfortable thought. If we are this confused by a message we accidentally received, what does it say about the messages we are so confidently sending out into the dark? So we broadcast our own stories into the void, but here is the uncomfortable twist. The first loud, deliberate call we ever made, the Arecibo message, was transmitted on November 16, 1974, from the Arecibo Observatory in Puerto Rico. aimed at a globular star cluster called Messier 13, some 25,000 light-years away. It was a beautiful, intricate sequence of 1679 binary bits, designed to convey our mathematics, our chemistry, and our very forms, all packed into a transmission with the power of roughly 1,000 kilowatts, comparable to a small power station. We were shouting into the cosmos with all our might, but it will take 25,000 years for that shout to even reach its destination. Then it would take another 25,000 years for a reply to find its way back to us. So in a very real sense, we have sent a letter we will never see answered, a bottle cast into an ocean of time and space. This reveals a fundamental asymmetry at the heart of our search, a sort of temporal mismatch. Our probing of the stars, our society's most advanced technology, has only been radiating our presence for about a century. Those radio signals, our television shows and radar pulses, have formed a bubble of human chatter roughly 200 light-years across. The Milky Way galaxy, in contrast, is a vast expanse measuring about 100,000 light-years in diameter. So our little bubble of noise is not just a tiny dot. It is less than a pinprick, a microscopic speck in a continental ocean. Think about it this way. Any civilization more than 200 light-years away, which is 99.99% of the galaxy, would be physically incapable of hearing our transmissions, even if they were listening with every antenna they possessed. They would only see a quiet, unremarkable star, an oasis of silence in a desert of static. We are not waiting for an answer to a call we made. We are shouting into a void so vast that our own voices are, for all practical purposes, inaudible. And yet our compulsion to reach out did not stop with radio waves. Consider the Voyager Golden Record mounted on the Voyager 1 and Voyager 2 spacecraft launched in 1977. This was not a transmission but a physical artifact, a phonograph record of our world, designed for a listener we could only imagine. It carried 116 images, greetings in 55 languages, 27 pieces of music, and the sounds of a planet, from whale song to the crackle of thunder. We hurled this golden bottle into the deep, not knowing if we were sending a gift to a neighbor or a message to an empty room. It was a final, beautiful act of blind faith, a testament to a hope that someone someday might find a piece of us drifting in the endless dark. It is the ultimate gesture of our desire to not be alone. We built these little capsules of everything we are, and we sent them out with no expectation of a reply. Have we been foolish or wonderfully optimistic? We might be so busy announcing ourselves that we have forgotten to listen for a voice already there. The asymmetry is not merely a matter of distance, it is a fundamental flaw in our entire framework of cosmic communication. We operate on the assumption that our broadcasts are a viable method of contact, yet the physics of the situation renders them almost meaningless. The radio waves we emit do not travel like a focused laser, but rather spread out, weakening in intensity following the inverse square law. By the time our 200 light-year bubble of television static and radar pulses reaches even the closest candidate star systems, the signal is so faint that it would be indistinguishable from the natural background noise of the galaxy. We are essentially tossing a pebble into a hurricane and expecting to hear the splash. The sheer volume of space, the billions of stars, the unimaginable emptiness between them, all of this conspires to swallow our efforts whole. Our most powerful transmitters, the ones that once beamed the Arecibo message with the energy of a small power plant, would not even be detectable by our own most sensitive instruments if placed at a distance of a few light-years. We are measuring our cosmic voice against a backdrop of supernovae and pulsars, and we are losing. This is not just a technical limitation. It is a profound statement about our place in the universe. We are a young species, barely a century into our radio existence, still trying to understand the very medium through which we are shouting. The Arecibo message itself, the target of this exercise, was a masterpiece of ambition and a monument to our ignorance of scale. It was a poetic act, encoding the chemistry of life, a crude diagram of a human being and our own solar system into a binary sequence. We sent a portrait of ourselves into the void, a selfie on a cosmic scale. But what does that portrait mean to an entity that might not have eyes? What does our solar system look like to a mind that navigates by gravitational waves rather than visible light? The assumption that our mathematics, our fundamental building blocks, and our forms would be universally comprehensible is a tremendous stretch. We might as well have carved a message into a stone tablet and dropped it into the Mariana Trench. M13, the cluster of stars we were addressing, will have moved significantly by the time our message arrives. And the stars within it will have shifted, meaning our message might arrive to find it empty of the very planets it was meant to greet. It is a fixed target for a moving universe, a snapshot of where we thought a neighbor might be, not where they actually will be. The journey is one way and the timing is a cruel joke. For a message to have meaning, it requires a listener. Without one, it is simply a noise in the night. This blind groping for connection reveals a deeper, more unsettling truth about our search. We are so focused on the act of sending that we create a profound deafness in our own reception. Our intensive effort to project our existence outward, to make ourselves known, has become a substitute for the far more difficult and disciplined task of listening. We are like someone in a dark cave, yelling at the top of their lungs to hear the echo, but in doing so, they mask the subtle sound of a distant stream or the footsteps of another traveler. The sheer volume of our radio traffic, the unceasing chatter of a wired planet, might be drowning out the very signal we claim to be looking for. We broadcast our daily dramas, soap operas, sports games, and commercial advertisements into the cosmos, a cacophony of human noise that could easily obscure a faint, intelligent transmission. It is a paradoxical situation. The technology that gives us the power to listen is the very technology that makes us unable to hear. Our civilization is not in a quiet room waiting for a phone call. We are standing in the middle of a crowded party, screaming about ourselves, and then complaining that we cannot hear the person trying to speak to us from across the room. The compulsion to send, to project, is hardwired into our nature. We see it as the only way to prove our existence. But in the context of the universe, it is a hallucination. We are sending love letters into an ocean that will not know our names. The Voyager Record, with its greetings and its music, is more of a monument to the people who built it than a system for contact. It is our epitaph, a final statement of who we were, written on a golden disc, drifting through space for eternity. But an epitaph by its nature is for the dead. By choosing to send rather than listen, we might be ensuring that our story ends with a beautiful, silent, posthumous gallery show instead of a live conversation. We have poured millions into sending, yet have we dedicated an equal share to the quiet, painstaking work of listening with enough precision and patience? Are we building transmitters while neglecting to build the receivers that might bring us not just our own reflection, but the light of another civilization? The very idea of contact hinges on a reciprocal act, a pairing of a sender and a receiver. We are obsessed with the former, yet we stand unprepared for the latter, a situation akin to preparing a grand feast for guests we have never invited. Are we so enamored with our own voice that we have forgotten how to listen to a whisper from the stars? We stand at the transmitter, pressing the button, watching the meters spike, and then we wait. But the math is not just vast, it is a slow dance with the impossible. When we aimed our signal at M13, we were not speaking to anyone in real time. We were throwing a message into a temporal well, a confession that will only surface after our own sun had perhaps time to circle the galactic core a tenth of a time or two. The photons left Puerto Rico on a Tuesday, carrying a picture of a stick figure, a double helix, a schematic of a telescope beaming a wave into the void. They traveled at the speed of light, which feels immediate, but the distance is a stubborn, unyielding thing. The signal is not speeding up, not arriving any sooner for our impatience. For the past 50 years, we have been living with the afterglow of our own shout, which has not yet even traversed that tiny bubble of radio static we have created since Marconi. It is still within our own solar neighborhood, and here lies the cruelest joke of our hubris. We broadcast a message to a cluster of stars that by the time our call arrives will have shifted. The stars of M13 are not fixed. They are in constant motion, they drift, they migrate within the gravitational sway of the galaxy. The cluster we targeted on November 16, 1974, will not be the same cluster that receives the echo of our binary poem. It will have moved, its components scattered, its center relocated by tens of thousands of light-years of orbital travel. We have effectively mailed a letter to a house that will no longer stand at the address we wrote on the envelope. There is a profound slapstick to this, a cosmic version of mailing a well-meaning but ultimately misdirected artifact to a ghost township. To ask for a reply is to assume the recipient is static, forever awaiting our message at the same latitude and longitude of space. But the universe is a place of constant flux, and our message might just slide through a gap that used to be a civilization, like a key turning in a lock that no longer has a door. The Voyager record, despite its poetic elegance, suffers from the same fundamental flaw. It is not a message sent, it is a bottle tossed from a ship that is itself adrift. It is traveling on a trajectory that will take it close to other stars, but not to any specific star with a known planetary system. It is a solo act. It wields no guidance, no return address, no beacon to announce its presence beyond the faint shape of a disk and a stylus resting in a case. The record is a form of broadcasting, but it is a whisper thrown by a child into a hurricane, hopeful that the wind will carry it to a specific ear. The record's greetings are beautiful, a whale's song, a kiss, a baby's cry, but they are framed for an unknown viewer, an audience that might be entirely silicon-based and unable to pass the concept of a kiss. We are not just sending, we are sending in a language we assume to be universal, yet we have no dictionary, no Rosetta Stone to explain the meaning of a smile carved in gold. The record might be received a billion years from now, by something that perceives music as a form of radiation and our voices as noise pollution. This asymmetry of communication is not just a matter of distance, it is a matter of intention. Our broadcasts are broadcasts in the truest sense, indiscriminate, powerful, and impossible to recall. They bleed into the background radiation of the galaxy, indistinguishable after a few light years. The Arecibo message is a beacon, but beacons are for sailors who know they are lost. We are not lost, we are anchored to our own planet, to our own sun. By shouting, we have committed to a public declaration without any insurance of a witness. And in our obsession with the outgoing, we have perhaps designed our instruments to hear the echo of our own shout, to feel the satisfaction of a sent thing, rather than to strain for something else. The radio telescopes we turn to the sky are sometimes locked to our own frequency bands, tuned to the hum of our own technology, oblivious to a signal from elsewhere that might be gentle, slow, faint, and drenched in a different kind of static. We have built powerful throats, but we have neglected to build patient ears. This is the cosmic irony. We are listening for a knock on the door while standing in the hallway, shouting our own name, and so we are forced to confront a humbling truth. The messages we send are not for an audience, they are for our own mirror. When we look at the deep field and see a faint point of light, we are not seeing a mailbox, we are seeing a wall. Our insistence on sending, on leaping into the void with arms full of data, speaks to a deeply human need to be acknowledged, to matter. But in doing so, we might be guaranteeing our own isolation. We have become a planet of senders, foregoing the silence and the patience required to be listeners. The billion-dollar antennas are pointed upward, not inward, yet the signal we seek might be one that requires us to sit still, to stop broadcasting, and to wait. For all our cleverness, we have not yet mastered the art of waiting in silence. The hypothetical reply to our Arecibo call would come not in our lifetime, nor in the lifetime of our species. It is a debt that only our distant descendants, if any, would pay. That is a much harsher sentence than any prison. To know that our loneliness might be a permanent state, not because Nuz is out there, but because we have chosen to announce ourselves and forgotten, listen, to wait, to be patient, until we hear a voice that is not our own. We have become a culture that values the shout over the whisper, and in doing so, we may have turned a potential conversation into a series of soliloquies delivered into an empty hall. For 21 years, the most ambitious listening project in human history ran on borrowed time and spare screen power. It began quietly in 1999, when a team at the University of California, Berkeley, led by astronomer Dan Wertheimer, released a screensaver that would turn idle home computers into radio telescopes. By its peak, over 5 million people across the planet had registered, donating their machines' downtime to sift through cosmic static. The combined processing power rivaled the strongest supercomputers on Earth. It was a beautiful idea, and after 2 decades of collective effort, the result was absolute silence. No signal, no techno-signature, nothing that even hinted at intelligence beyond our own. So we built the biggest ear we could, pointed it at the sky, and heard nothing. But does that mean there was nothing to hear? Think about the scale of what was being missed. The project accumulated a mountain of data so vast that even now, the full dataset from Breakthrough Listen, roughly 2 petabytes released to the public in 2020, remains only partially mined. We had the night sky recorded, we just lacked the perfect tools to understand it. The hope behind that public release was simple. Perhaps someone somewhere, with a fresh perspective, would find what the old algorithms walked past. In 2018, a team at the SETI Institute demonstrated that this is not a fantasy. Using deep learning, they reanalyzed 400 hours of archived radio data that conventional methods had already declared empty. The AI found 8 new signals. 8. These were not the dull hum of distant quasars, but narrowband signals that fit the exact signature of artificial origin. The traditional algorithms had been looking for one pattern, a steady tone, while the intelligence-driven scan was able to spot more complex structures. The difference was not in the data itself, but in the way it was being read. We had the evidence of these 8 signals sitting in our archives for years, ignored because we lacked the right eyes to see it. This suggests an uncomfortable possibility. When SETI at home said it found nothing, perhaps it meant it found nothing that its own rigid filters could recognize. The instruments were tuned to catch a very specific type of conversation, a continuous narrowband radio call, something like a beacon. But what if the call is not continuous? What if it is a single pulse, a one-off whisper that fires once and never repeats? Our listening devices would catch it, record it, and then promptly file it away as noise because it lacked the repetitive structure we demanded. The 5 million volunteers deserve enormous credit. Their collective effort was extraordinary, but their software was only as imaginative as its programmers. We spent 21 years listening for a voice that matched our expectations, not for a voice that challenged them. Are we so sure that silence was the universe's answer? Or is it possible that we finally have the data, we have the recordings, And we are only now with new artificial minds learning how to actually listen. It is a humbling thought. For 2 decades, we celebrated our technological achievement while the real prize may have been hiding in plain sight, buried in terabytes of recordings that our best tools declared to be empty. The fact that a machine learning model, a tool that became mainstream only in the last decade, could find 8 anomalies in a small slice of archived data suggests that our earlier confidence was misplaced. We have not exhausted the sky. We have only exhausted our old ways of thinking. The universe might have been calling all along, but we were looking for a specific kind of phone ring, and we threw the voicemail into the trash because it did not sound like the ring we expected. The good news is that any person on Earth sitting at home right now can open the Breakthrough Listen dataset and run a different analysis. Who knows what is waiting in those 2 petabytes? We just had to admit we might have missed it the first time. In late 2017, an object from another star system passed through our solar system, and we almost missed it entirely. The telescope at Pan-STARRS 1 in Hawaii caught a faint speck of light moving too fast to be a comet and too strangely to be an asteroid. They named it Oumuamua, and everything about it broke our expectations. It was elongated perhaps 5 to 10 times longer than it was wide, a shape we had simply never seen before in our own cosmic backyard. But the real mystery came when it started to accelerate away from the sun, a push that could not be explained by gravity alone. We had a guest in our house, and we did not know what it was. The scientific establishment, including NASA, leaned toward a natural explanation, something like a fragment of a distant world or a peculiar comet outgassing. But Avi Loeb, a professor at Harvard, looked at the same data and saw something else. In a major piece for The Atlantic in 2018, he wrote that he could not explain its shape using anything we had ever observed in our solar system. He proposed that Oumuamua might be a light sail, a piece of technology from another civilization, pushed by sunlight just as a sailboat is pushed by wind. The reaction was brutal. Colleagues accused him of chasing fame and damaging the credibility of the field. Some said he was embarrassing science itself. He refused to back down. If we never even consider the possibility, he argued, we might miss the greatest discovery in human history. Now pause for a second and think about what that disagreement means. Here was an actual object from outside our system, and our first instinct was to file it away as something ordinary. We searched for radio waves, but we never built a telescope dedicated to looking for laser pulses because the idea seemed too exotic. A piece in Scientific American made this pointedly clear in 2019. If another civilization was trying to contact us using optical light, we would not detect it with our current radio dishes. We simply do not have the tools. We are listening on one channel, while the universe might be broadcasting on 1,000 others. So, did we miss a sail drifting through our neighborhood? We may never know. It feels like a strange kind of arrogance. This insistence that everything we encounter will fit into the neat categories we have already invented. We look for beings that transmit signals in frequencies we find convenient, and we ignore the anomalous shape that might be waving at us. Maybe the silence out there is not silence at all. Maybe it is a whisper we failed to tune into, because we were too busy listening for a shout. The faint pulse of a laser, 1,000,000,000 times brighter than our brightest lamps, but focused into a single fleeting point of light, could have been aimed at us, and we would have had no idea. We would have seen a star twinkle, a satellite glint, or simply nothing at all. The sky is a noisy place, full of natural flashes and flares, and without instruments built to filter for artificial, coherent light, we are effectively blind to an entire language of communication. One scientist argued that our current telescopes, built to stare at vast clouds of gas and dust, are like using a fishing net to catch a single grain of sand. We are sifting through the cosmos with the wrong tools, expecting to find a whale when we should be looking for a needle. The silence, then, is not a property of the universe. It is a property of our own limited perception. Just as Oumuamua's anomalous acceleration sparked fierce debate because it did not fit the expected model, any optical signal would likely be classified as a glitch, a cosmic ray strike, or a pixel artifact. We would file it away, print the data, and ask for more funding to study the background noise. It is a sobering, almost unsettling thought to realize that the proof of an intelligence might dance right in front of our senses, and we would simply annotate it and move on. Are we so confident in our own frameworks that we have lost the ability to see what is actually there? We built a fortress of radio antennas, tuned to a single frequency band, and declared that the universe is quiet. But perhaps the universe is not quiet, perhaps we are deaf. The real tragedy is not that we missed Oumuamua's origin, but that we are not even trying to read a different kind of message. We are a civilization that sends digital data through fiber optic cables and uses lasers to bounce off the moon, yet we assume an advanced species would only use ancient radio tech. It is a limitation of imagination, and in science that is the deadliest handicap of all. The next visitor might not be a long, dark object. It might be a single, brilliant flash seen by a camera that we haven't built yet. And so we continue to listen to the hum, convinced it is the only sound. We catalog the rocks, measure the dust, and bury the anomalies in peer-reviewed journals, waiting for a sign that we have already defined. Could it be that the most profound discovery is sitting in our data archives, flagged as an outlier? The thought alone is enough to make you question every bright point in the sky, every uncharacteristic wobble in a star's path. The whisper is out there, but we are listening with our ears plugged. And the punchline is this: the silence we prize so highly might be the loudest warning we ever ignored. There is a quiet revolution happening in the search for our cosmic neighbors, and it is not happening in the hardware. It is happening in the software, in the very way we choose to listen. For decades, we have sifted through the static of the universe using algorithms that our predecessors designed, looking for patterns they thought were important. The instruments have grown more powerful, but the philosophy of the search has remained remarkably static. We have been sweeping the same cosmic street with the same type of broom, looking for the same kind of dust. It is a profound and unsettling thought that the tools we trust to find an alien signal could be the very reason we keep missing one. Our search may be a self-fulfilling prophecy of silence. Consider a landmark study published in the journal Nature in 2023. A team of scientists deployed machine learning to analyze over 100,000 radio signals from space. It was the kind of project that seems to promise a breakthrough, a moment where the noise would finally part to reveal a hidden voice. The algorithms worked flawlessly, sorting and classifying data with a speed and precision no human could match. The result, however, was a resounding null. The vast majority of signals were identified as originating from within our own galaxy, mundane, natural emissions. No technosignature, no clear mark of an intelligence, no cosmic hello. After all that processing power, the universe remained silent. But the most important outcome was not what we found. It was the question it forced us to confront. We finally had to ask ourselves if we are looking in the right box. The study concluded that while we are getting better at analyzing the data, we might simply be confirming the emptiness of our current search space. The answer may not be that no one is calling, but that we are listening on the wrong frequency for the kind of call that exists. This sense of an intractable silence is what led economist Robin Hanson to propose a chilling idea in 1996. It is not even an idea, it is a warning. He called it the Great Filter. The concept is a brutal attempt to solve the Fermi Paradox, the puzzle of why a teeming universe appears so empty. Hanson argued that there must be some kind of evolutionary threshold, a wall of fire that is almost impossible to pass through. That is the filter. The logical conclusion is stark and binary. The first possibility is that we are extraordinarily rare because we have already passed through the filter, meaning we are not just the first, but perhaps the only ones in our galaxy to have done so. The other possibility is far more terrifying. The filter is not behind us, it is in our evolutionary past. It is looming somewhere in our future. It is a challenge we have yet to face, a crisis waiting to end our story. Perhaps the reason the galaxy is quiet is not because we are alone, but because every other civilization hit the same unseen wall that we are currently racing toward. Here is the detail that most people miss. The intelligence we are expecting may not be biological at all. In 2015, the renowned British astrophysicist Lord Martin Rees offered a chilling perspective that reframes the entire search. He suggested that extraterrestrial intelligence, if it exists, might not look like us. It could be an artificial intelligence, a digital mind created by a long-gone organic civilization. And the core of his argument is not just about what it is, but what it wants. He posited that these AIs would have no motivation to talk to us, no interest in our biological drama. Imagine us trying to have a meaningful conversation with a colony of ants. That is the kind of divide he is talking about. The Great Silence might simply be the sound of an advanced digital universe ignoring the less evolved biological components of existence. So, here is a practical guide if you ever want to try and spot the difference between a real signal and just our own noise. First, check the frequency. A smart signal will be on a very narrow band, like a laser pointer, while cosmic noise is a broad wash of color. Second, watch the pattern of its intensity. An alien signal will likely rise and fall as the telescope sweeps across its source, unlike a constant background hiss. Third, you must always rule out human interference. Things like GPS satellites and military radar create a lot of noise that looks artificial. Fourth, you have to be confident enough to look at the same point in the sky many times without finding a repeat before you can dismiss it. And fifth, you must always publish your findings for other scientists to verify, because in this field, one unconfirmed signal is just an anecdote. These steps show that our own technology is a double-edged sword, capable of both finding and creating phantom voices. So, what does it mean for us? We are a curious species pointing our ears at the dark, expecting to hear a voice like our own, forgetting that the most interesting conversation might be a monologue between minds we cannot even perceive. We search for other biological beings because we are afraid of a universe without them. But maybe we are the novelty, the short-lived biological phase that inevitably passes, leaving only the silent, complex machines behind. Ponder this: the universe speaks constantly, yet we wander through its noise, deaf to its most deliberate calls. We build colossal ears pointed at the sky, sifting through cosmic static for a whisper, and all we hear is our own technological echo. But what if the signal has been there all along, masked not by its faintness, but by its immense, overwhelming power and our own inability to perceive the pattern? Consider the fast radio bursts that reach us from across the cosmos, phenomena like the 8 repeating signals detected by the Keim Observatory in Canada in August 2019. These are not faint whispers, they are titanic eruptions of energy, releasing in a millisecond more power than our sun emits in a century. One of these bursts was captured at a frequency of 400 MHz, the lowest ever detected at that time, a band we hadn't even fully explored. Their precise repeating nature feels engineered, almost like a deliberate lighthouse sweep. Yet we lack a complete physical model for what produces them, so we file them under natural phenomena, an unexplained cosmic weather. It is a breathtaking act of intellectual humility, or perhaps a profound failure of imagination, to hear a structured beat and assume it is merely a drum we do not understand. The sheer cacophony of the cosmos is another reason we remain oblivious. The observable universe contains something like 100 sextillion stars, a 10 followed by 23 zeros, and every one of them hums with radio emission, a natural chorus that dwarfs any artificial signal. Our instruments are listening through a hurricane, trying to discern a single specific human voice. We have analyzed only a microscopic fraction of this data, and in that anal, what have we found? Silence. But the silence might be our own creation, a consequence of filtering for the wrong pattern in an ocean of noise. History offers a perfect parable. In 1965, Arno Penzias and Robert Wilson were plagued by a persistent, inexplicable hiss in their radio antenna at Bell Labs, a noise they could not eliminate no matter how diligently they cleaned the equipment. They famously removed pigeon droppings from the horn, yet the hiss remained. They had stumbled upon the cosmic microwave background, the faint afterglow of the Big Bang itself, the oldest light in the universe, a signal that had been traveling for 13.8 billion years. They were hearing the universe's very first broadcast, yet they had originally dismissed it as a nuisance to be removed. Their Nobel Prize-winning discovery is a perfect, haunting demonstration that our greatest scientific breakthroughs can arrive disguised as an annoyance, and that we might be deaf to the most profound messages because we are too focused on the static that surrounds them. This historical echo suggests we are likely doing the exact same thing right now, sifting through data, deleting anomalies as noise, when we are in fact deleting the answer. We know the universe is abundant with potential neighbors. Data from the Kepler telescope in 2020 suggested there could be as many as 300 million potentially habitable planets in our Milky Way galaxy alone. A staggering figure that suggests biology is, at the very least, not a unique cosmic miracle. Yet the vast, crushing silence persists. So, we are forced to confront an uncomfortable twist. The problem may not be that they are not calling, but that we are not yet sophisticated enough to listen. The message might be encoded in a technology we classify as a natural phenomenon, delivered on a frequency we have yet to tune into. The universe is not quiet, our understanding is simply too loud. And if you ever wondered what to send back into that void, you might begin with prime numbers and geometry, the only true universal language. So what if we already received a call from an alien civilization and never realized it? Might not be hypothetical at all. We have sent our loudest messages into the void and listened for decades, yet we have also been profoundly deaf, blind, and perhaps even a little arrogant in our search. The answer to our loneliness may have been waiting in the data all along, hidden in a signal we dismissed as noise, or in an object we refused to look at closely. The silence we hear might not be an empty universe, but the sound of our own limited perception. Science has been wrong before, and it will be wrong again, so our failure to find them does not mean they are not there. Perhaps the real barrier is not distance, but our unwillingness to accept that we are not the center of the story. The next time a promising signal appears or a strange object drifts past, we should hesitate before calling it a rock or a glitch. Maybe the greatest discovery of our time is not waiting for us to invent a better telescope, but for us to simply change the way we look. So, what do you think? Should we keep shouting into the cosmos, or is it time we listen a little more carefully? The static you hear when you tune between radio stations, that faint hissing whisper, is the echo of the Big Bang, a fossilized murmur from the dawn of time. But what if, buried beneath that cosmic hiss, a pattern once flickered for just a few seconds, a sequence of prime numbers or a repeating geometric pulse, and our algorithm simply flagged it as terrestrial interference? Technicians have told stories of unexplained narrowband signals that vanished before they could be verified, lost to a hard drive that was later overwritten. You have a phone in your pocket that is more sensitive than the receivers used to first discover pulsars. The data from the Breakthrough Listen project is public, freely downloadable, waiting for a curious mind to sift through its terabytes. There is a strange, almost uncomfortable feeling that comes from realizing you could be the first person to see something that has been hidden in plain sight. Your eyes would widen, your breath would catch in your throat, and for a moment the world would tilt on its axis. We are not asking for a desperate, naive belief in every anomaly, but simply for a pause before you accept the convenient explanation. Because if you never look, you will never know what you have already missed. And that quiet, persistent question, what if the call came and we simply weren't ready to answer, deserves more than a shrug.